all I'll get through is just a couple things about the graphing. What does absolute value do? Makes everything positive. Essentially what it does is it gives you the distance from 0, and a distance is always positive. You know, when I'm talking about the distance between Monroe City and Hannibal, that's the same as the distance between Hannibal and Monroe City. It's not one positive and one negative. So distance is positive. That's why absolute value makes everything positive. Why don't you guys put that Chromebook away so you're paying attention. Thank you. All right. So I want to take a type of function that we've been looking at, and I'm going to do something to it. So first, I want to give the domain and range of this function. And probably the easiest way to give the domain and range would be to graph it. What is my parent function? X squared. So 0 squared is 0, 1 squared is 1, negative 1 squared is 1. You could do more points if you wanted, 2, 4, negative 2, 4. All right, what's my transformation this time? What does the minus 4 do? We go right 4 and okay. Oops. So take of each of these points, move them right 4 and down 3, and our graph ends up here. Can you tell me the domain and range of that?
Negative infinity to positive.
And what's the range?
Negative 3 to positive infinity.
Good. All right, so that's like something I would have asked you before. So now, what if I said the absolute value of this? If something is positive, does the absolute value change it?
No.
No. So these positive parts are going to change, but what's going to happen to all these negatives?
Become positive.
Right, so this point was at 5, negative 3, and it's going to go to 5, positive 3. This point was at 6, negative 2, so it would go to 6, positive 2. 4, negative 2, come up here. So the positive part of my graph doesn't change. But that part that was negative is just going to get flipped up to be a positive.
W.
So this red one is the graph of the absolute value. So all the absolute value did was took the negative section of the graph and flipped it up. What's the domain of that?
Negative infinity to positive.
Right. Doesn't change my domain at all. But what's my range now?
0 to positive infinity.
Good. Because if we did the absolute value, we're only getting positives when we look at it. So the absolute value really just changes the range, the y values. It makes those positive. X can still be anything. All right, let's practice like flipping a graph like that. So I'm going to give us a couple graphs already drawn, and we're just going to see if we can visualize what would happen if we did the absolute value of it. Okay, so here is a graph. Got a couple functions here. So if I asked you for the absolute value, what part is going to change on this first one? Yeah, that pink part. And so I went ahead and drew the final part for you, and I showed you all that happened is that pink part got flipped above the axis. Okay, so do you guys understand this is the original and this is the absolute value? Okay. What's the domain of the original?
Negative 25.
What is the range of the original?
Negative 35.
What's the domain of the absolute value?
Negative 25.
What is the range of the absolute value? Good. So far, so good? Let's try one more. So what is y equals 2x minus 1?
Linear.
That's linear. So if you add the graph a line, what do you do first? slope and y-intercept, right? What's the y-intercept of this line? -1, so you start at -1. What's your slope?
2.
So you go up 2 over 1.
What? Hold on, huh? Wouldn't you be at 0 if you went up 2 from where you're at?
I'm at -1.
Oh, snap. Yeah, you're right. Sorry. You said
Okay.
absolutely into that.
Alright.
Clock it out.
If I ask for domain and range, what is it on that?
-2.
Both name infinity, pass infinity. Alright, so then if I ask for the graph of the absolute value, what part gets switched?
Everything.
This part basically gets flipped up. The point where it hits the x-axis doesn't change, and all the positives stay the same. It's really kind of crooked, but. So this orange part is the absolute value.
So basically, you just showed us an easy way
Yeah.
to do what we just did.
So this is just talking about how absolute values change a function. The last thing we're going to write down today is a few rules. Tomorrow we're going to solve equations and inequalities, so I want to get the rules written down today, and then tomorrow we'll just pick up with examples. All right, so when you did this in Algebra 2, you probably broke it up. You did equations for a few days, and then you did inequalities for a few days, and we're just going to put them all together. With an equation, if you have the absolute value equals a number, okay, absolute value is distance from 0. If I said the absolute value of x is 2, that means on a number line, my number is 2 units away from 0. So the number could be +2, or it could be -2, right? Both +2 and -2 are 2 away from 0. So the rule is, and I want everybody to have this written in your notes, you have to do 2 equations. X could equal a, or x could equal a negative a. So if you have an equation, you set it equal to the positive and negative, and you will get 2 answers there. When you have a less than, so if I said the distance between x, or the absolute value of x is less than 2, that's saying it's within 2 units from 0. Okay, so it could be anything all the way up to +2, or all the way down from -2, and anything in that window would work. So when you see this less than, did Mrs. Keller talk about how that was like an and statement? Less than.
Greater.
It's an and greater is an or. So this is my and. So did she do, there's 2 ways we could write it. Did she do it like this, or did she write?
We also did.
You also did the 2 separate ones?
Yeah.
I like this one.
You like this way better? Alright, that's how I usually do it, but I can flip if you guys don't like that. So when you see the less than, that's an and statement, so we make one big inequality. Great or, so that's my or statement, so we do 2 separate ones. It could be x is bigger than a, or x is less than negative a. When you do the negative, you have to flip the inequality. So these are the rules we'll be using tomorrow.